Hello, my friends. Last time we were talking about waves, and we learned about what a wave is, the types of waves, mechanical, electromagnetic. We talked a little bit about how um, waves have vibrations or caused by vibrations, um, how the medium can vibrate either up and down or back and forth. A transverse wave is back and forth. I'm sorry, transverse wave is up and down, and a longitudinal wave is one where the particles vibrate in the direction of the wave. And today we get into a little bit about what does a wave look like and what are the parts of a wave. So you're going to fill in your notes as I go through them here, and we're going to jump in with the crest. So the crest is like the highest part of the wave, and go. And a crest, highest part of a transverse wave, it looks like um, the part right here. That's the crest, right? And please pause if you want to write the definitions down in your notepad. The trough, that's the part of the wave that's the lowest. It's like the opposite part of the crest, the lowest point of a transverse wave. Um, Basically, the flip version of the crest is the trough, which would be right here. And then the amplitude is how tall the wave is. Oh, geez. So we said it's the maximum distance the particles of a wave's medium vibrate from their rest position. So basically, how tall the wave is. Okay, the amplitude is this measure right here of how tall, and the amplitude would be the same whether you measure it from the medium middle point to the top or from the middle point to the bottom. The amplitude is the same. Waves also happen not just like when you're vibrating a string like in this picture, but also if you were to have a spring and like push the spring back and forth. It's the same idea. It's just in a direction. This would be a longitudinal wave where the wave is compressed in the direction. The spring is compressed in the direction of the wave. So the crowded areas, those are called compressions. And the stretched, so that would be like right here, compressions. And then the stretched out areas are called rarefactions. And those are the ones that would be like right here. And then the amplitude is how close together they get. You don't have to worry about the amplitude for a longitudinal wave. It's just basically how smushed together things get. But this spring lines up very clearly with a wave of like a string, and you can see how it all lines up. Okay. So we can measure the distance between two parts of the waves that are similar, and we call that the wavelength. So the distance from one point on a wave to an identical point on the next wave, that's the wavelength, and it's easiest to identify it like right here. The wavelength is the top of the crest to the top of the next crest, or the top of the bottom of the trough to the next trough. You get the idea. That's called the wavelength. And wavelength is measured by the Greek letter lambda, so it's kind of like an upside down y, which you'll use a lot in the next video when you do some math with it. The period is how long for the wave to pass through you. A lot of waves pass through you very, very fast, whether they're like light waves and sound waves are still very, very fast. But some waves move very, very slow, like let's say a wave in the ocean or something. So how long does it take to pass? That is called the period, a complete cycle. How long it takes from one crest to the next crest, we call that the period of the wave. And period is represented by a capital T. And then we also have frequency as measures the rate of vibration. So how often is a wave passing through you? We call it the frequency, the number of vibrations per unit of time. Usually frequency is the cycles per second. And the symbol for frequency is F is the symbol. The measuring it is hertz, Hz. Maybe you've heard of hertz. Well, when like you tune your radio in your car, megahertz, 101.3 kWb, that's like the call letters, but the 101.3 is the actual frequency of the radio station measured in megahertz. So it's how often or how many waves pass through your car in per second. And I don't know what the picture is. And I'm going to show you the equations actually on the next page, the next video. But that is a list of the things that you would need to know for them. And we jump around a little bit here. Frequency is 1 over period, 1 over capital T, which we'll use in a minute. And one other thing we like to know about wave is the speed. And the speed of the wave is frequency times wavelength. And I have a handful of videos that will allow you to see some of those equations, and we're going to try them next. But hopefully that gives you an idea of what a wave looks like and what two equations we use, what kinds of things we can measure, and then how they're related in equations. And when you watch the next video, you'll see some of the triangles what you would use to solve those equations. Thanks. Bye.